Welcome to Java Internals, Interview Crashcasts, the podcast that helps you ace your next Java interview. I'm your host, Shayla, and today we're joined by Victor, a senior Java developer, to discuss a common interview question for backend engineers. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to share my knowledge and help our listeners prepare for their interviews.
Great. Let's start with our question for today. What are the different ways to create threads in Java?
That's a great question, Sheila. At its core, there are two primary ways to create threads in Java. The first method is by extending the thread class, and the second is by implementing the runnable interface.
Could you elaborate on these two methods, Victor? How do they differ?
Certainly. When you extend the thread class, you create a subclass of thread and override its run method. You then instantiate this subclass and call its start method to begin execution. On the other hand, when you implement the runnable interface, you create a class that implements the run method, and then pass an instance of this class to a new thread object.
Interesting. Is there a preferred method between these two?
Generally, implementing the runnable interface is considered better practice. It provides better separation of concerns as the task logic is separate from the thread behavior. It also allows for more flexibility, as Java doesn't support multiple inheritance, so extending thread limits your class from extending other classes.
That makes sense. Are there any other ways to create threads in Java?
Yes, there are more advanced methods. One popular approach is using the executor service from the java.util concurrent package. This provides a higher-level replacement for working with threads directly. You can submit runnable or callable tasks to an executor service, which manages a pool of threads to execute these tasks.
That sounds useful. How about some more modern approaches?
Absolutely. With Java 8 and later versions, you can use lambda expressions to create threads more concisely. For example, you can create a thread using a short, anonymous function that prints a message. This approach is much more readable and concise than the traditional methods.
Very interesting. Now let's dive a bit deeper. Can you tell us about the internal workings of threads in Java?
Certainly. Internally, Java threads go through various states in their lifecycle. These states include new, runnable, blocked, waiting, timed waiting, and terminated. Understanding these states is crucial for managing threads effectively.
That's fascinating. How about thread priorities? Do they play a role in how threads are executed?
Yes, they do. Java threads have priorities ranging from 1 to 10, with 5 being the default. Higher priority threads are generally executed in preference to lower priority ones. However, it's important to note that thread scheduling is ultimately up to the underlying operating system, so priorities are more of a hint than a guarantee.
Interesting point about priorities. Now, let's consider some edge cases. What should developers be aware of when working with multiple threads?
Great question. When working with multiple threads, developers need to be very mindful of thread safety. Shared resources can lead to race conditions if not properly synchronized. It's crucial to use synchronization mechanisms like synchronized blocks or methods, or utilize concurrent collections from the Java.util concurrent package to ensure thread-safe operations.
Could you give an example of a potential pitfall?
Certainly. One common pitfall is deadlock. This occurs when 2 or more threads are unable to proceed because each is waiting for the other to release a lock. For example, if thread A holds a lock on resource X and is waiting for resource Y, while thread B holds a lock on Y and is waiting for X, we have a deadlock situation.
That's a great example, Victor. As we wrap up, what are some best practices you'd recommend for working with threads in Java?
Great question. Some key best practices include: first, prefer using high-level concurrency utilities like executor service over managing threads directly. Second, always use proper synchronization when accessing shared resources. Third, avoid blocking operations in threads, especially in GUI applications. Fourth, be cautious with thread priorities and don't rely on them for correctness. Fifth, use thread-safe collections when working with multiple threads. And finally, always handle interrupted exception properly to ensure threads can be shut down gracefully.
Excellent advice, Victor. Thank you for sharing your expertise with us today. To our listeners, remember that understanding thread creation and management is crucial for any senior Java developer. Practice these concepts and don't be afraid to dive into the Java Concurrency API documentation for more advanced topics. That wraps up our episode on thread creation in Java. Join us next time for more Java Internals interview questions.